Have you ever asked yourself, why do I still have to study mathematics? Maybe you've said it before. Maybe you're even thinking about it right now. After all, you survived elementary school mathematics. You finished junior high school mathematics. You passed senior high school mathematics. So, why another mathematics subject? Today, I'd like you to meet someone. His name is Alex. Today is his first day in college. Just like many freshmen, Alex is excited, is nervous, is hopeful, and just like many students, he has one question: will I ever use mathematics in real life? Today, let's follow Alex, and by the end of his day, let's see if we can answer that question together. Alex wakes up. He checks the time, looks outside. The sky is cloudy. He pauses. Should I bring an umbrella or leave it at home? Instead of guessing, Alex opened his phone. He checks the weather forecast. Have you ever done the same thing? Maybe this morning, maybe yesterday, maybe every single day. Now, I want you to think about something. How can your phone tell us what tomorrow's weather will be when tomorrow hasn't happened yet? Can your phone predict the future, or is something else happening? So, in 1 minute, I want you to think in that question. How do you think weather forecasts are made? Okay, so after 1 minute, feel free to pause this video and comment your ideas in our comment section. So, yeah, scientists don't guess, they collect data: temperature, humidity, air pressure, wind direction, wind speed. Then they use mathematics to recognize patterns because mathematics help us make decisions. So, Alex finally leaves at home. He's excited. It's his very first day in college. Everything feels new: the campus, his classmates. Every journey to school feels different. As he rides the jeepney, he notices something. Almost everyone is looking at their phone. Some are checking the weather, some are checking the Google Maps, others are checking stock prices. Someone beside him is reading the basketball news. Another passenger receives a flood advisory notification. Alex smiles. He realizes everyone is trying to answer the same question: what will happen next? And then a thought enters his mind. Wait a minute. How do all these apps know the future? Can a phone really predict tomorrow? Can Google Maps really know where traffic will happen? Can businesses know whether prices will increase? Can coaches predict who will win the championship? Or are they simply making educated guesses? Actually, they're doing something much more powerful. They recognizing patterns. And whenever people recognizes patterns, they are already using mathematics. Now, I'd like you to think about your own life, not Alex, yours. Turn to the person beside you. For the next 2 minutes, take turns answering this question: where do we use prediction in everyday life? Okay, so I want you to give one example, and maybe you have a person beside you, give another. Okay, weather is one example, traffic, online shopping, business, sports, flood warning. Exactly. Notice something interesting. No one said, I use mathematics. But every example you gave depends on mathematics. That's because mathematics often works quietly behind the scenes. Most people never notice it, yet they use it every single day. So, Alex begins: maybe mathematics isn't really about numbers. Maybe numbers are just one small part of it. Let me ask you something. When you hear the word mathematics, what immediately comes to your mind? Many students answers formulas, equations, problem solving, calculators, examination. Some even say stress, right? And honestly, I understand because that's how many of us first experience mathematics. But today, I'd like to challenge that idea. Suppose I remove every number from mathematics. No numbers, no equation, no formulas. Would mathematics disappear? Not really, because mathematics begin much earlier. It begins with patterns. A baby recognizes patterns. Birds recognize the season. Plants recognize sunlight. Your phone recognizes your face. Even your favorite songs follows patterns. Before mathematics became numbers, it was already helping people understand relationships. That's why mathematicians describe mathematics in very different ways. Some call it the study of patterns. Other calls it the language of symbols. Some describe it as a science of relationship. And perhaps the simplest definition is this: mathematics is the tool that help people solve problems. Now think back: the weather app, the Google Maps, business forecasts, did they simply calculate numbers or did they first recognize patterns? Exactly. That's why the weather example best matches our first definition. Mathematics is the study of patterns. So, after orientation, Alex rides another jeepney. Everything is going well until everything stops. Traffic. Cars aren't moving. The driver sighs. Passenger begins checking the time. Some are worried they'll be late. Others become impatient. Alex looks at his phone and suddenly Google Maps flashes a message. A faster route is available. He follows it. A few minutes later, he arrives much earlier than expected. Now, here's something amazing. Google Maps didn't have a helicopter flying above every road, right? Nobody called Google and reported the traffic. So, how did it know? Think about this. Thousands of people are carrying smartphones, right? Each phone quietly shares anonymous location data. Google notices that hundreds of cars suddenly slow down in one area. When thousands of people move slowly, a pattern appears. And mathematics recognizes that pattern. It predicts the fastest possible route. Notice something. Mathematics didn't create the traffic. It simply understood it. Now, this idea of prediction becomes even more important because sometimes we don't just predict traffic. Sometimes we predict typhoons. Now, imagine this. Pag-asa is tracking a typhoon at exactly 2 p.m. on Wednesday. They record its location later at 2 a.m. Thursday. Then they record another location. Now imagine you're the weather scientist. Someone asks, where was the typhoon around 8 p.m. Wednesday? Can you answer that? Actually, yes. Even though nobody measured it exactly 8 p.m. Because 8 p.m. lies between two known observations. Scientists estimate its location using the surrounding information. That process is called interpolation. Now let's change the question. Instead of asking about 8 p.m., someone asks, where will the typhoon be 3 days from now? It's different. We're looking beyond the available information. Scientists must project what is likely to happen next. The process is called extrapolation. Notice something beautiful. Both methods begin with the same thing: reliable data. Without good data, there can be no good prediction. And mathematics give us the tools to make those predictions responsibly. The next morning, Alex walks through the university gates. He stops for a moment. Everywhere he looks, students, hundreds, 10,000s, some are attending orientation, others are looking for a classroom, some are meeting for new friends. Alex quietly asks himself, this university is huge. Then another question enters his mind. How did the university know? How many classrooms to build? How many teachers to hire? How many chairs to prepare? Did they simply guess? Or of course not. Universities don't wait until students arrive. Before they start planning, they study enrollment patterns from previous years. They estimate how many students are likely to enroll next year. They prepare before the students even arrive. I want you to think about that. Long before Alex walked through these gates, someone had already prepared a seat for him. Not because they knew Alex personally, but because mathematics helped them plan ahead. That is one of the greatest powers of mathematics. It allows us to prepare today for tomorrow. And that's exactly why, in our next example, we'll see how mathematics models population growth to help governments and institutions make long term decisions. Alex is finally inside the university. Orientation is about to begin. He looks around, and for the first time, he notices something he completely ignored earlier: students. Everywhere, thousands of them. Some are excited, some are nervous, some are taking selfies, others are searching for their classroom. Alex quietly smiles. Then he wonders, how did the university know all of us were coming? Think about that. This morning, before any of you walked through these gates, your classroom was already prepared. Your chair was already waiting for you. Your professor already knew what lesson to teach. Electricity was already on. The air conditioning was already running. Nobody waited until you arrived before they prepared. Why? Because someone planned ahead. Now, imagine you're the president of the university. You know what that next year, even more students may enroll. What questions would you need to answer? Do we need more classroom? Do we need more teachers? Do we need another laboratory? Will our parking spaces still be enough? Those are difficult questions, but mathematics helps transforms those questions into plan. Imagine that all of you are members of the University Planning Committee. Each group has one mission. How can mathematics help school prepare for future enrollment? Remember, every member of your group has a number. When time is over, I'll call random number that the students will answer on the behalf of the group. So, in this case, I want you to use the comment section. If you have ideas, just comment it in our public chat. So, I think some of you mentioned that it's about budgeting. Others talk about classroom. Some mention teachers. Okay, so I think that's exactly we want to know. And I want you to notice something. Nobody can accurately prepare for tomorrow unless they understand today's numbers. That's why mathematics doesn't only predict the future, it helps us prepare for it. And one of the tools we use is called a population growth model. Let's see how it works. So, in this case, there is a population growth model. Don't let the formula scare you. So, whenever students see a formula, many immediately think, I'll understand this. But today, I want you to look at differently. So, imagine you're baking a cake. No, would you throw all the ingredients together without measuring? Of course not. You measure it in the ingredient one at a time. Mathematics work exactly the same way because we'll take this formula one ingredient, one step at a time. So let's begin. Our city currently has 500,000 people. Every year, its population grows by 2%. What might happen 10 years from now? So I want you to notice we're not trying to predict the future perfectly. We're making the best estimate using today's information. That's exactly what governments do. So here is the population growth model formula. So we have the initial population. So we want to substitute it. So the initial population is 500,000. We have the E there. There is a value for E. The population growth factor is 2%. And the time what it take is 10. So when we simplify that, we must simplify first the zero point 0.2 times 10. That is going to be 0.2. Okay? And then we find the value for e raised to 0.2. Type it in your calculator. That is going to be approximately 1.2214. And then we multiply it to the initial population or the current population, 500,000. The answer must be 610,700 people. So now, think about that. That's more than 110,000 additional people. So imagine the impact. That is more homes, more hospital, more schools, more food, more transportation. That's why mathematics matters because behind every number are real people, real families, real communities that occur in that particular model. Okay, so here that evening, Alex finally arrives home. He's tired. He turns on the television, breaking news, COVID 19 updates. For a moment, he remembers the pandemic. Maybe he remembered it too. Schools were empty, streets became quiet, families stayed inside. Some of us celebrated birthdays through video calls, some missed graduation ceremonies, some lost loved ones. Every evening, the news reported numbers: 50,000 cases, 70,000 cases, 100,000 cases. At a time, many people asked, why are they always talking about numbers? Now Alex understand. Those weren't just numbers. Every number represented a person, a family, a hospital bed, a doctor working overtime, a community hoping life would return to normal. Mathematics helped leaders understand what was happening so they could make better decisions. Sometimes numbers tell stories, and sometimes they saved lives. So let's look at a number that became very important during the pandemic. It's called doubling time. Suppose there were 50,000 confirmed cases. So that's the initial cases. So the final cases would be 100,000. What's the first thing we notice? Okay, so I think the step one is to divide 100,000, the final cases, to the initial cases. So that would tell us that the cases will double, and also the time would it take is 15 days. So the doubling time is 15 days. Okay, so now that means if nothing changes, okay, the number of cases could double again after another 15 days. Now, imagine if the doubling happened every 5 days instead. Would that be better or worse? Of course, that's worse. Because a shorter doubling time means the disease spreads much faster. And that's why health officials watch these numbers so carefully. Not because they love statistics, but because every decision affected real people. Again, mathematics wasn't replacing compassion, it was helping people protect lives. So let's go back to Alex. This morning, Alex believed mathematics was only about solving equations. But now, everything feels different. He realizes mathematics help him choose whether to bring an umbrella, avoid traffic, understand how universities prepare for students, understand why governments study population growth, understand why health officials monitor COVID 19. Then Alex asks himself one final question: what about me? When did mathematics quietly help me today? Now, I want you to ask yourself the same question. Not Alex, but you. Take 30 seconds. Think about your day from the moment you woke up until this very moment. Where did mathematics quietly help you? After that, share your answer with your partner. Listen carefully to one another. You may discover that mathematics has been part of your day more often than you realize. When you finish, complete these exercises. So let's finish where our story began. This morning, Alex looked at his class schedule and wondered, why do I still have mathematics in college? Now, I wonder if his answer has changed. I hope yours too. Because today, we didn't just study mathematics, we discovered where it quietly lives: in weather forecast, in navigation, in schools, in hospitals, in public safety, and in the decision we make every single day. So, before you leave, I'd like you to complete one sentence. Not using the book, not using Google, use your own experience. Complete this statement. Mathematics is because there are no identical answer because every one of you experienced today's lesson differently. And next time, Alex will notice something unusual on campus. a sunflower. At first, it will look ordinary, but hidden inside it is one of the most beautiful mathematical secrets in nature. And that's where our next adventure begins: the sunflower secret, the Fibonacci sequence, and the golden ratio. I'll see you in the next lesson.